Hi, my name is Sharare Zehtabian. I'm presenting a unified approach to ads relevance prediction for multiple relevance objectives. First, let's see what is ads relevance in search. Consider a user or pinner that comes to Pinterest to find new ideas about kitchen renovation. We want to show the ads of products that are highly relevant to what user was looking for, such as these ads in this picture. Our goal here is to predict relevance score of an ad for a given query or context. Given a query or context, there are multiple ads that can be selected to be shown to the user in the search surface. So we have an ads auction that takes ads relevance score as one of its inputs in order to deliver the right ads to the user. We can classify relevance of the ads based on the context, and in order to do this, we need data. Our benchmark data includes examples labeled by human. We have 5 different ratings or labels, starting from rating equal to 1, which is completely irrelevant and even could be offensive to the user, to rating equal to 5, which is completely relevant and completely matched with what user was looking for. We propose using ordinal classification models. First, we tried multitask ordinal. For the base layers in our architecture, we have 2 fully connected neural network layers, and each layer is followed by a dropout layer with rate of 0.1. Then in the final layer, we have 4 nodes, and each node outputs the probability of being greater than a rating from 1 to 4, and it has a sigmoid activation. We need to encode the labels to an ordinal encoding with size of 4. So for example, for label equal to 3, the ordinal encoding is 1100. We compute the probabilities of each rating by using these formulas. For example, for x equal to I, we can compute it by using px greater than I minus 1 minus px greater than I. Second, we tried individual binary classifiers. We trained for the individual binary classification models, and each model is trained separately based on a threshold from 1 to 4. And finally, we used Coral ordinal model that uses consistent rank logits. And this approach can ensure us that px greater than 1 is always greater or equal to px greater than 2, and so on. For experimental studies, we use 2 baselines. One baseline is binary classification model that binarizes different relevance grades to relevant and irrelevant. Second, we used multi-class classification model that classifies using softmax. For having fair comparisons, we used the same base layers as ordinal models. We evaluate the models on the benchmark data that includes about 20,000 examples. We report the PRAUC, precision recall area under curve. And we binarize the true labels with using 2 different thresholds, 3 and 4. We calculate the relevance score by getting the weighted average of probabilities for each rating. In this table, you can see the results for all of the approaches. The first observation was that binary classification can perform well in separating relevant ads from irrelevant ads. However, it didn't work well for separating relevant ads from marginally relevant ads. We observed that all of the ordinal classification models perform well in separating relevant from both irrelevant and marginally relevant ads. Also, multi-class classification performed well, but it had more false positive comparing to ordinal classification models. As a conclusion, we explored a unified approach to ad relevance prediction using ordinal classification models. Binary classification performs well to classify relevant from irrelevant ads. However, it didn't perform as effectively in separating relevant from marginally relevant ads. All of the ordinal classification models perform well in separating relevant from both irrelevant and marginally relevant ads. Thank you so much for listening.